So, question 9. Giuseppe wishes to set up an annuity. He's told that an annuity with a quarterly, so I've highlighted that to remind myself we're doing things quarterly, is modeled by this recursive rule. The next term is the one before times 1.019 minus P, so that's how much he's taking out, starting off with Q. And the values of P and Q consistent with this spreadsheet. So here's the opening balance. So that's got to be Q. So in the table beneath, part A asks us to work out what P, Q, X and Y are. So Q has to be the opening balance, 648. What else do we need? What's P? So P is how much we're withdrawing. So there's the payment is 15,000. So that's P. I noticed in the table here a little bit of an inconsistency. Up here it was called an investment return. Now it's called an investment gain. But I'm guessing everyone knows that a gain is the same as an investment return. Although investments don't always go up, they might go down. So that's a little bit dodgy. Anyway, what do we need? X and Y. So X is the closing balance. So to get the closing balance, we take the opening balance, add the gain and subtract the payment. Let's grab a calculator. Here we go. So let's tidy up from the question we were doing before. We've got $648,000 and we are subtracting from that 12,312, the interest for the month. And oh no, we're adding that one. Let me just add that in. We're adding the interest and then we're subtracting the payment of 15,000. So this is the value of whatever fellow was missing, X there. And then the value of Y is, where is Y? So the closing balance would go forward to be the opening balance for the second quarter, and then Y is the interest on that balance. So we need to multiply this by the value we just calculated, X, by 0.019. Let's do it. So now we'll just on the next line times by 0.019. And there's the value of Y. We obviously need to round it to the nearest dollar and cents. So $12,260.93 goes into there. So we move on down. What is the annual compound interest rate for the investment? So it's the 0.19 is the quarterly rate. So we need to multiply it by 4 and 100 to get 7.6% per annum. So that's done. When the balance in the annuity first falls below 300,000, the perpetuity is converted. It's converted into a perpetuity. The interest rate remains the same. How many years before the perpetuity starts? Now, it's only 2 marks, so we really don't need to show any working on this one. We could again use the recursive rule that they gave us in the question, or I'm going to opt maybe here for the financial, using finance to do this one because it might be just a little bit quicker. So here we go. I'm going into the financial app. It's a compound interest problem. N is what I want to find. The annual interest rate is 7.6. The present value of our loan is 600 and it's negative technically, so 648. We've worked hard and saved it up and taken the money out of our pocket, put it in the bank, and they're paying us back at the rate of $15,000 per quarter. So down here, payments are happening 4 times, and the interest is compounded at the same rate. Let's just double check that. The interest rate remains the same as that in part B, so 7.6, and the annuity is basically quarterly. So yep, we're all good. And the future value, so that will be, we want to know when the future value falls to 300,000. That'll be positive because at that stage we could take the money out of the bank, put it in our pocket and go off and have a bit of a holiday or something. Anyway, now we just want to solve for N. So we tap N, 65.9 payments. So basically that's going to be 66 payments. Now the question asks for the number of years. So I'd say first off that it'll happen after 66 quarters. And then if we change that number to 66 and divide it by 4, then that turns out to be 16.5 years. So don't forget we can do calculations in these boxes. Right, let's move on to part D. So part D, what are the quarterly payments under this perpetuity? So now we're back into here, and we know, well, let's just go back. So after 66 payments, we wouldn't have exactly 300,000. Let's work out what we've actually got slightly less. So that would be the first thing I'd write down, is that this is our future value. And so we basically, this has got to now become our present value and stay also as our future value. So let's round it up to the nearest dollar and cents. So that 8 will round the 6 up to a 7. Then I'll clear the number out of this box, take this one and drop it in. So, but now it goes to negative because I put the money back into the savings account, and I want to make sure that we maintain this future value. So I just need to solve for the payment. And the payment is $5,690.52. And again, this was a 2 marker, so we don't need to really put any working down if we're confident that we've worked out the payment properly. But I think we'd probably say that the future value is this, so therefore to maintain that amount, we need to withdraw this amount. Right, and on to the last part of the question. So we've got to use a clear calculation to decide whether the effective interest rate is 7.93% or not. So I'll grab my calculator now. While I'm still in the financial app, we could just quickly check out what it actually is using interest conversion here. Put in that the annual rate is 7.6. that we're compounding it 4 times, and the effective rate is 7.82. So obviously it's not, but the question asks for a clear calculation. Probably the best way to do this is I'm going to use my e-activity here. So here we've got the effective interest rate. If I tap on the I for information, it reminds me what's got to go in the boxes. But here's the basic formula. So to convince the examiner to give me the marks, we're basically going to write this formula down over here on our bit of paper. Only where we get to R, we'll put in 7.6 as the interest rate, and N will go in as 4 up here, and otherwise, and N of course downstairs here as 4. And then when we tap solve, here it is again, 7.82%. So basically, or if you thought you could just take the original multiplier, raise it to the power of 4, you'll realize we get the same thing. Either way, his belief is wrong. We'd say the effective rate is only 7.82.